Hey guys, here we have a paper 2, grade 12, from November 2023. If you want to download the paper, just check the description below. Truck drivers travel a certain distance and then they have a rest before traveling further. A driver keeps record of the distance traveled on 8 trips and the amount of time that he rested before he continued his journey. Okay, so for example, when he traveled 180 kilometers, he then rested for 20 minutes. When he traveled for 200 kilometers, then he rested for 25 minutes. So now the first question says, determine the equation of the least squares regression line. So that is a formula that is on your formula sheet, right at the end of the formula sheet. And so you need to go plug this data into your calculator and then get the A and the B value. You can also get the correlation coefficient, which is the R value, which is something that they're asking for over here. So let's go plug all this data into our calculator now. So your first step is just to put your calculator into stat mode, and then don't use 1 minus VAR, that's grade 11 statistics, use A plus BX, and then just go input the data. So for example, 180, then I do the next X value, which is 200, then 400, you get the idea. And then after that's all done, then you're going to go to the Y column and you're just going to start doing the Y values like 20, 25. Okay, so I'm not going to let you watch all of that. You get the idea. Once all the data has been input, then you can just press the AC button, press Shift, press the number 1, then go to 5, which stands for regression. And then there we can get our A, B, and R. So for A, you press 1 equals... Just want to write that down and we'll keep it to 2 decimal places. So minus 23.85. Then to get B, you're just going to go shift 1 again, 5, and then B, press equals 0.23. And then I'm just going to go get the R value as well because they do ask us that in question 1.3. So you just go here and then R is with the 3, but then press equals 0.98. Okay, so we can then fill in our equation because we now know that A is negative 23.85, B is 0.23, X. Okay, so that's question 1.1 complete. 1.2. If a truck driver travels 550 kilometers, so that's the X value, predict the time that he would rest. Okay, so you just use your formula and you see these are the X values and they gave us the X value as 550, like that. And if you do that, you should get 102.65 minutes. Next question, write down the correlation coefficient. Well, we worked that out, remember, as R, which was 0.98. Now they're asking you to comment on that. So remember that I've told you that if you get 1 or minus 1, that is a perfect correlation. But anything bigger than 0.8 is going to be strong, or anything, so let me quickly show you on a number line. So if you can have minus 1 and 1, then you get like 0.8, 0.5, that's negative, that's negative. Okay, let's do this a bit better. Let's put 0 there, 0.5, 0.5, and then 1, minus 1, minus 0.8, 0.8. So typically anything more than 0.8 and then smaller than there, that is considered to be very strong. The negative just means that the gradient is negative. It doesn't mean anything else, so that's strong. Okay, so if you're getting 0.98, that is going to be a strong. Now, because it's positive, you must say positive. So you can say strong positive correlation. At each stop, the truck driver spends money on food. The amount spent in rands is given below. Okay, so at the first stop, the person spent 100 rand, 150 rand. Calculate the mean. So mean is easy. You just add all these numbers together and divide by how many numbers there are. So you can also do it on the calculator. If you have to input all the data, then it does also work on the calculator, but I'm not going to go through that now. If you know how to do that method, you can do it. Plus 50, plus 180, plus 200, plus 190, divided by how many numbers there are, which is 8, and that's 150 rand. So on average, this person spends about 150 rand each stop. Calculate the standard deviation. Okay, now this one we're going to put the data onto the calculator. Okay, so you're going to put your calculator into stat mode. Now you're going to use the grade 11 of 1 minus VAR. You're going to input your data, 100, 150, 130. You get the idea. Once all the data has been input, you can press AC, press Shift, press 1. Now, because it's a grade 11 statistics, you're going to go to VAR. And then here you can get different things. If you press number 2, that'll give you the average, which we worked out as 150. If you look at the number 3, it's got like a little weird apple funny sign. That is your standard deviation. Press equals, and there we go. 50.50 if we round to 2 decimals. 50.50. So 50.50. This one says, at how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? Okay, so the mean is 150. The standard deviation is 50.50. So they want to know if you go 1 standard deviation less than the mean. So that means you're going to go 150 minus 50.50, and that'll give us 99 Rand 50. 99 Rand 50. So they want to know, at how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? So in how many stops did the driver spend even less than that? So that would be only once. So 1. At a certain school, the staff committee wanted to determine how many glasses of water the staff members drank during a school day. Okay, so for example, there are 5 staff members who drank between 0 and 2 glasses per day. There are 2 staff members who drank between 8 and 10 glasses per day. Complete the cumulative frequency. Okay, so a cumulative frequency, they'll give you a table in your exam where it'll just say cumulative. Cumulative just means total. So up till this point, there's only been 5 staff members. Up till this point, there's been 20 staff members because 5 plus 15 is 20. Up till this point, there's been 33 because now you're adding on 13. Then it's 38 because you're adding on 5. And then if you add on 2, 40. So there should be 40 staff members altogether. How many staff members were interviewed? 40. How many staff members drank fewer than 6 glasses per day? So that would be this category, and this category, because the 6 is not included. So this is less than 6, this is also, and this is also. So you add up those 3 numbers together, and that'll give you 33. The staff committee observes that K teachers were absent on the day of the interviews. It was found that half of these K teachers drank from 0 to fewer than 2 glasses of water per day, while the remainder of them drank between 4 and 6. Okay, so there were K teachers that were absent. Half of them are in this category, and the other half are in this category. When these K teachers are included, the estimated mean is 4. How many teachers were absent on the day of the interviews? Okay, so we know that in this category, there's now going to be a few extra staff members. So there's going to be another K over 2 staff members. Why do I say K over 2? Well, you can say half K if you want. Because we said there are K teachers that were absent. Half of them went into this category, and the other half are in this category. So this can also be a half K. So how would you normally calculate the mean? We've looked at this on a table before. You look at the mid number over here. So that's going to be 1, 3, 5, 7, and 9. And then what we do to calculate the mean, I'm going to get rid of this quickly, is you simply say this number multiplied by this number. We've done this on tables before, hey guys? So 1 multiplied by 5 plus half K plus 3 multiply 15 plus 5 multiply 13 plus half K plus 7 multiply 5 plus 9 multiply 2. Now to calculate the average, you normally divide by how many members there are. So there's 40 members originally plus another K members. So we can say 40 plus K. And we know that the average should be equal to 4. Okay, so let's just neaten this up a little bit. That's just going to give us 5 plus half K. This is just going to give us 45, 65. I'm just multiplying this in. Plus 2.5k, because 5 times a half is 2.5, plus 35, plus 18, over 40 plus k, and all of that should be equal to 4. Now I'm just going to simplify a little bit. So 5 plus 45 plus 65 plus 35 plus 18. If we add all of that together, we get 168. And then if you add these together, that'll give you 3k. And then over 40 plus k. And that's all equal to 4. I'm going to cross multiply now. So we end up with that. I'm then going to multiply the 4 in. Okay, now I'm going to take the k over to the other side. So it'll end up being 4 minus 3, which is just k. And then I'm going to take the 160 over to the left. And so k must be 8. In the figure, L, S, and N are the vertices of a triangle. First question, calculate the length of SL. Okay, so that's just going to be distance formula, which is then just going to be x2 take away x1 plus y2 take away y1. So let's maybe say this is 0.1, this is 0.2. So now you just go fill in the formula, which is x value of point number 2, which is minus 4. X value of point number 1 is 4. Y value of point number 2 is 1. Y value of point number 1 is 5. Okay, go ahead and just type that all in on the calculator, and you should get 4 square root 5. Leave your answer in a square root because they said leave your answer in surd form. Right, this question. Calculate the gradient of Sn. So these are easy marks, hey guys, because this is just using formulas. So y2 minus y1 over x2 minus x1. So this is now for Sn. So we can call this point number 1, for example, and this number 2. You can do it the other way, it doesn't matter. So minus 3 minus 5, and then minus 2 minus 4. That'll simplify to 4 over 3. Calculate the size of theta. Okay, so we've spoken about this before. We know that if you have gradient, then we can use tan to get inclination. So we can just simply say shift tan of the gradient, and that'll give us the angle. 53.13 degrees. There we go. Calculate the size of angle N. Okay, so whenever they give you this situation, I've seen them do this a lot, where N is a little angle here. All you do is you make a triangle with the horizontal. You want to be able to use a horizontal because now we know this angle. So that means we know this angle. Now we can just use this line, get its inclination angles, and then it's easy to quickly come into this triangle and work out that. They do this a lot. So we can, for example, go work out this angle just because of vertically opposite of here. So we can just say that that's angle KON, and that's going to be equal to 53.13 degrees because of vertically opposite angles, vert, op, angles. Okay, so we have this angle. Now we can work out the gradient of this line. So the gradient of LN, gradient formula. You can call whichever one you want 1 and whichever one you want 2. It will give you the same answer. And so 1 take away minus 3, and then minus 4 take away minus 2. And if we had to go work this all out, we end up with negative 2. Okay, now when you get your inclination angle, don't use negative 2, just use positive 2. So shift tan of 2, and that'll be 63.43 degrees. Now, if you look at this area over here, where do you think the 63.43 is? Is it this one? Or is it this one? Oh, it's this one. It's the smaller one, okay? It's the one that's less than 90 degrees. So this is going to be 63.43 degrees. So that means this angle, because of vertically opposite, would also be 63.43. So we could say that angle NKO is going to be 63.43 degrees. And that is because of vert opposite angles. So now we have this angle. And now we can just use sum of angles in a triangle. So angle N, or they called it LNS, let's rather do that, is going to be 180 minus 63.43 minus 53.13, and that is because of sum of angles in a triangle. And so that'll be 63.44 degrees, 63.44 degrees. Determine the equation of the line which passes through L. Okay, so it passes through L and is parallel to Sn. Okay, so if y is equal to mx plus c, if two lines are parallel, So it's a line that goes something like this, more like that. So these two lines are parallel. So they have the same gradient. So therefore the gradient of this line will be 4 over 3, like we worked out for Sn earlier. To find C, you just plug a point on this line. Can you see one? There it is. It's L. So the y is 1. The x is minus 4. And so if you had to work out C, you end up with 19 over 3. And so y is 4 over 3x plus 19 over 3. Calculate the area of triangle LSN. So triangle LSN. Oh, it's the whole thing. Okay, so they want the area of that entire triangle. So there's different ways to get area. Let's try to use what we already have. So we already have the length of SL. Okay, so that means if we could simply get the length of this one, then we can just use the half base times height because it's got the 90 degree. So let's go get the length of LN. So the length of LN is going to be, you're going to use the distance formula. And so let's say, for example, this is 0.2 and this is 0.1. And so then if we just go fill this all in, it's going to be minus 4, take away minus 2, and 1 take away minus 3. And so if we had to go work this all out, you get 2 square root 5. And so now to work out the area, we can just say half base times height. So it doesn't matter which one uses the base and which one uses the height. So we're going to say, let's say it's the length of LS and then LN. And so that's going to be half times 4 square root 5, which is what we got for SL earlier. And then 2 square root 5, which is what we've just got now. And so that's going to be 20. And they didn't really give us units, so we'll just say units squared. This one says, calculate the coordinates of point P, which is equidistant from L, S, and N. So point P is equidistant from L, from S, and from N. That would mean then that LSN could be a circle, and point P would have to be the center of that circle. Because then, to all places, that would be the radius. But we already know that this line must be the diameter of that circle because only a diameter could make a 90 degrees. So that means point P is somewhere on this line over here. So to find out exactly where that is, you could just go find the, let's just do this a bit better. You could just go find the midpoint of these 2 points. So the midpoint of SN is going to be the midpoint formula, which is x1 plus x2, y1 plus y2 over 2. So we could, for example, call this point 1, and we could call that point 2. So that's going to end up being minus 2 plus 4 over 2, minus 3 plus 5 over 2. And so that's going to end up being 1, and minus 3 plus 5 is 2, also 1. Okay, so point P would be 1 and 1. When a point is equidistant from other points, you could just make P the center of the circle, and if you have a center of a circle, then the distance to any point on that circle is the same because it's the radius. So that could be like L, N, and S. It would be equidistant. Okay? And then I said that point P must be somewhere on, because when I made the circle, I realized that this is making a 90 degree. And that can only happen when you have angles in a semicircle. And that only happens when you have a diameter. So that means this line here was the diameter. And so I knew that my center must be the center of my diameter, which was there. And so I just did the midpoint. Okay. Now the last question for this one says, what is the angle LPS? Only for 2 marks, thank goodness. LPS. Oh, P is over here. So from L to P to S. Well, that's a fairly straightforward one because I know that this length and this length are the same because they are the radii of a circle. So that means this angle and this angle have to be the same because this is a isosceles triangle that we're making over here. So There's multiple ways you could do this, but if you, for example, look inside this triangle here, we already know this angle. We worked that out, LNS. We worked that out as 63.44. We know this is a 90 degree, so then we could easily get that angle up there. So angle S would be 180 minus 63.44 minus 90, and that is because of sum of angles in a triangle. And so angle S would be 26.56 degrees. So that's this one, 26.56. But that would mean that this is also 26.56. So that would be angle PLS would also be 26.56, because those are the angles that are opposite equal sides. So this is 26.56. So then to work out this one, you can just use sum of angles in a triangle. And so that's going to be 180. Oh, sorry, maybe we should write it out a bit better. Angle LPS is going to be 180 minus 26.56 minus 26.56. And that is because of sum of angles in a triangle. And so that angle is going to be 126.88 degrees. In the diagram, the circle with center O has the equation x squared plus y squared equals to 20. So that's this one. X squared. No, that's not how you do x squared, Kev. X squared plus y squared is 20. Sorry, guys. Exam nerves. G is T0 is the center. A common tangent touches the circle D and F such that D, which is... okay, that's interesting. So that's information that they haven't shown us. P minus 2 lies in the fourth quadrant. Okay, cool. Given that D lies on the smaller circle, show that P is 4. That's very easy. Because we have the circle's equation, we know P is the x, minus 2 is the y. So you're just going to go fill that into the circle's equation. And then you're going to end up with this being a positive 4. That's going to be 16. So technically P would be plus or minus 4 when you take the square root. But because it's in the fourth quadrant, x has to be a positive. And so therefore P would have to be 4. Point E, which is 6 and 2, which is over here, is the midpoint of DF. Determine the coordinates of F. Okay, well that's easy because we now know what P is. So we can use the midpoint in reverse. If you have D, E, and you have F, and so then D would be 4, negative 2, E would be 6, 2, and then F is X and Y. So just use the midpoint theorem. We know that with the midpoint theorem, you normally use this information and this information to find this one. So you'd normally say x1 plus x2 over 2, and y1 plus y2 over 2. Now we can do that again, but you would say, so for example, point D, let's let that be point 1, and then let's let point F be number 2. So you would say 4 add x over 2, but we know the answer. We know that the x value midpoint is 6, so we can make it equal to 6. And then for the y, we can say minus 2 plus y over 2, and we know the y answer must be 2. Okay, so you're just going to solve this one now. Take the 2 over to the other side, so that'll become 12, because 6 times 2 is 12. And then if you take the 4 over, you would end up with 8. And then here you can multiply this 2 up. So you end up with minus 2 plus y equals to 4, and then y would be 6. So the coordinates of f then would be 8 and 6. This question says, determine the equation of the tangent df. Okay, that's an easy one. Hey guys, I don't know why that's worth 4 marks. Because we have the coordinates. Well, I guess we have to go get the gradient and all of that. But it's not difficult. So we can go work out the gradient of df. Gradient formula is y2 take away y1 over x2 take away x1. So you could, for example, use this as 0.1, this is 0.2, doesn't really matter. Minus 2 minus 6 over 4 take away 8. And if we simplify that, that should give us 4 minus 8. It should give us 2. Okay, so we know the gradient of that line now. To find c, you plug in any point on that line. You can plug this point, or this point. It doesn't matter. I'm going to use this point. So 6 is the y, 8 is the x, and so you end up with that. and that. So the final answer for that question would be y equals to 2x take away 10. Y equals 2x take away 10. Calculate the value of t, show all your working. So I think what we can do is, we already know this equation of that line, and we know that this is the radius of the circle, and this one is the tangent. So we know that a radius and a tangent are perpendicular. So because we know this one's equation, we know its gradient, all of that stuff, that'll easily allow us to calculate this equation. Once we have this one's equation, we can literally just plug in x as t, y as 0, and then solve. So we know that these two lines are perpendicular. So we know that their gradients, when you multiply them, so the gradient of fd, when you multiply that with the gradient of fg, mathematically it must give us -1, because we have a tangent that is perpendicular to a radius. Okay? And when two lines are perpendicular, the gradients multiplied always gives us -1. So we know this one's gradient. We calculated it there. It's 2. So if you had to work out the gradient of fg, it'll give you -1/2. So we now know this one's gradient. So we can then say y equals to -1/2x plus c. And then to find c, you plug in any point that you know on that line, which is just going to be this one, which is 8 and 6. So the 6 is the y, 8 is x, and so 6 is going to be -4 plus c, and so c is going to be +10. So the equation of this line is y equals to -1/2x plus 10. Now that we know that one's equation, it's very easy to find out point t, because all that we do now is we realize that t is the x, 0 is the y, so 0 is the y, x is t, and so we end up with that over there. I'm going to take the half to the other side, or the half t, and then if I try to get t alone, I'm going to divide 10 by 1/2, and so t should eventually must not give you 5, but instead 20. So the coordinates of t are 20. This one over here, 4.5. Determine the equation of the larger circle in that form over there. Okay, don't worry about that form right now. All we do is we just use the standard formula for a circle, which is x minus a, y minus b. And so if we have the center as 20 and 0, then it'll just be x minus 20, y take away 0, and then the radius. Okay, so we don't know what the radius is right now, but we can quickly work that out by just plugging in any x and y on the circle, on the edge of the circle. So we could use this point over here, which is 8 and 6. You could also go work out the distance between those 2 points. It's the same thing, actually. So we could go 8 minus 20. The y value is 6. And so if you just type this on your calculator, you don't even have to get r by itself. Just keep it as r squared. You get 180. So there, you don't need to get r alone. So we know the equation of the circle now in normal standard form. So we could say x minus 20, y minus 0 is just y, and then r squared is 180. So this is now your circle's equation. So how do we take it from there to there? Easy, just multiply all the brackets out. So we make double bracket, then like that. And so that's going to eventually give x squared. What I'm doing is I'm multiplying the brackets together. Minus 20x plus 400 plus y squared equals 180. Okay, now I'm just going to simplify. So minus 20 is minus 40. And then, okay, so they want the x squares first. Okay, we'll get that just now. And then we've got a plus y squared plus a 400 minus 180. You see they want everything to come onto the one side. Okay, so they want the x squares first, so x squared. Then they want the y squared. There it is. Then they want the x, which is minus 40. Then they want the y. There is no y. And then 400 minus 180, that is 220. There we go. Okay. The smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. For two circles to touch internally, or let's first talk about externally. Externally is when two circles look like this. That is external touching. This is external. Then internal is when you have something like this. That's internal. So they want to take this circle and they want to move it this way so that we get those scenarios taking place. Now, it'll happen twice. It could happen where the small circle gets there, but it could also happen if we move it to there. So I think all that we really need is to work out this coordinate here where it's touching the x-axis, and then we could work out this coordinate here, and I think from that we can work out, and we could probably also get this coordinate here, and from that we could work out how much we need to move in order to make that all happen. So let's go work out. So to get the x-intercepts of the small circle, so x-intercept of smaller circle, we obviously just make y 0. So if we have x squared plus y squared equals to 20, then x squared plus 0 is equal to 20, and so x squared is 20. So x would be, if you take the square root of that, and so that's going to be plus or minus 2 square root 5. And so that would be this point, and yeah, so minus 2 square root 5, and then this one would be 2 square root 5. Yeah, I think it's actually better to get this coordinate. Or no, both would actually work. Now we're going to quickly go get this coordinate over here. So, although, I don't know if you remember from this circle earlier, this big one, we went and worked out its equation earlier, and we found out that r squared was 180. So from that we can get its radius, which is 6 square root 5. So then if I know that this coordinate here is 20, then if I just minus 6 square root 5, I can easily know this coordinate. And if I plus 6 square root 5, I can get this coordinate. So this one would be 20 minus 6 root 5, which just stays 20 minus 6 root 5. And then this one would be 20 plus 6 root 5. Okay, so to be able to get this circle to land up over here, then I'm going to have to move it from this coordinate, which is 2 square root 5, all the way to 20 plus 6 square root 5. So how do I work out that horizontal distance? Well, what I could do is I could say scenario 1, and I could just say 20 plus 6 square root 5 minus 2 square root 5, and that's going to end up giving 20 plus 4 square root 5. So that's the one scenario. The other scenario is that I end up getting this circle, this point over here. And so to work out that translation, I would just say this value minus this value. And so scenario 2, 20 minus 6 square root 5 minus this this x value, which is also minus. And so that ends up becoming 20 minus 6 plus 2 is going to be minus 4 square root 5. So those are the possible values of k. And then if we want those as decimals, well, this one is going to be 20 plus 4 root 5, which is going to be 28.94. And then the bottom one, which is 20 minus 4 square root 5, is going to be 11.06 if we round to 2 decimals. Given that the sin of beta is 1 over 3, and beta is an angle between 90 and 270. So, on our cast diagram, 90 degrees is over here, this is 180, this is 270. So they said it's anywhere between 90 and 270, so that could be here or here. So which one is it? Well, they're telling us that the sin is a positive number. Can you see this is a positive number? So where is sin positive? That would be here. So what I'll now do is construct a triangle, and then you can just pretend that this is your beta angle. Now, remember that from SOHCAHTOA, sin is the opposite over the hypotenuse. So that means that this is a 1 and this is a 3, because I said 1 over 3. Now that the triangle is, well, we've got those two parts, now we can use Pythagoras to find this missing side. So we can just say 3 squared minus 1 squared, and that's going to give us, or actually we want to take the square root of that because of Pythagoras, and that should give us 2 root 2. So I'm going to put 2 root 2 there. I'm then going to put a negative because I know that this is the negative x-axis. There we go. Now we're just going to go solve these little questions. So what is cos of that angle? So cos from SOHCAHTOA is adjacent over hypotenuse. So that's going to be adjacent over hypotenuse. So that's going to be negative 2 root 2 over 3. Now it's the sin of 2 beta. Now you've got to be careful. You cannot look at this and look at that and think, oh, it's just going to be double, or anything like that. No. As soon as your mind says double, I want you to then think of the double angle formulas that we've learnt about in grade 12. You know, the one on your formula sheet where it tells us that the sin of 2a can become 2 sin a cos a. So now check this out. We already know what sin of beta is. It's 1 over 3. We've just calculated cos of beta. It was this. You can go ahead and actually just type that all on your calculator in one step. I know it says without a calculator, but they don't mind if you do the little parts. They just don't want you to like go do everything. Okay, so this would give you negative 4 square root 2 over 9. Negative 4 square root 2 over 9. Okay, cos of 450 minus beta. So I've told you guys that if this does not look like anything on the cast diagram, 180 minus, 180 plus, 360 minus, then you change it. How? By either adding or subtracting 360. Doesn't mean you must choose any one. You got to think about it. So this is 450. So we want to make that a little bit smaller. So we're going to subtract 360 degrees. So that's going to become 450 minus beta. And I'm going to subtract 360. And that ends up becoming 90 minus beta. Now that is a co-function over there. You know the 4 co-functions that we have. We've got this one, this one, this one, and this one. So this just becomes cos. This just becomes sin. This just becomes cos. And it's this one that becomes negative sin. So what we have is this over here, which is this one over here. So that just becomes sin beta. And we already know what sin beta is from the previous part already, a third. Given cos to the power of 4x plus blah, 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 prove that, okay, so pretty much prove the identity. Right, so here is our identity that we need to prove. So, I'm just trying to think where I can write this. So I'm definitely going to work on the left-hand side. So we could say left-hand side. And now we've got cos to the 4 plus sin squared x times cos squared x over 1 plus sin x. Right, first thing I would do at the top is just take out a common factor from these two terms. The common factor would be cos square x, and then what you would be left with over here is another cos square x plus. Now from here, we've taken this one out. So what are we left with? Sin squared. Okay, at the bottom, 1 plus sin x. Now, we know that that is equal to 1. So what we could then do is, I'm going to write over here, is just say cos squared x, and then that's just a 1. And then at the bottom, we've just got that. Now having a 1 there doesn't do anything. Okay, so this is where we're at this moment. Now, what I would do is I would actually change this from sin squared x plus cos squared x. We know that that is always equal to 1. So I'm going to get this by itself as 1 minus sin squared x. So that's going to become 1 minus sin squared x. Now the reason I've done that is because now this can become a difference of squares, because you've got two terms separated with a negative, and 1 times 1 gives you this, and sin times sin gives you that. So we can then rewrite that as 1 minus sin, 1 plus sin. Okay, no, that's messy, Kev. That's really messy. Let's go over there. So that's going to become 1 minus sin, 1 plus sin, over 1 plus sin. Now, these two can now cancel, and therefore we get 1 minus sin x, which is what they wanted. And so we could say, therefore, left-hand side is right-hand side. Okay, so it says, for what values is this expression undefined? So undefined is when you have a denominator that is 0. That is what undefined means. So we can say 1 plus sin x, and we can make that equal to 0. And then we can say, where is sin x equal to -1? Now, you can solve this using the whole quadrant reference angle. But whenever it's a 0, 1, -1, I like to actually just use the graph. That's a normal sin graph. And where is a normal sin graph equal to -1? Well, it starts here, which is 270 degrees. And if I had to keep going, it would repeat every 360. So I could say x is going to be at 270 plus multiples of 360, where k is an element of z. But now I just realized that they actually gave us an interval. So they just want it as that. Just the 270, because they gave us an interval. Okay. Now, this question says, write down the minimum. Don't use calculus. We don't use calculus in trigonometry, at least for grade 12. We don't do that. If you did university maths, there, of course, you're going to use calculus with trigonometry. But here it just says, write down the minimum value of this function. Now, this is an ugly function, but we know that this ugly function is also equal to that. So all we do is we rewrite it as that, and then we just analyze the question from that perspective. Some of you might be saying, well, Kev, why didn't we do that with this question? Well, that's because here we don't have a denominator, here we do. And to be able to do undefined, we want a denominator. Okay, so we're not going to look at this like I said, we're just going to look at this. Now they want to know, when is this thing a minimum? So you want to make this expression as small as possible. So to do that, we would want to make this part as big as possible, because if you can take this number and minus a big number, then you make this entire expression small. So if I look at a normal sin graph, the biggest I could ever make it is up here when it's equal to 1. So if this is a 1, then it becomes 1 minus 1, and that'll then be 0. Given that cos of a minus b is equal to that. Now that we already know from our formula sheet. What they're wanting us to do is says use the above identity to prove the following. Now this we already know is true on our formula sheet, but you're not allowed to use it. We're only allowed to use this. So we're given sin of a minus b, and we are only allowed to use this to somehow prove that it's that. So the first problem we have is that this only uses cos, but here we have sin. So we know that if you have like sin x, you can change it to cos of 90 minus x. But now this angle, or those angles, that is your x. So this is going to be rewritten as cos 90 minus that. So you're going to put it in a bracket like that. Now the next thing is we're just going to get rid of those brackets now. So it becomes minus a plus b. What I'm then going to do is put the 90 and the b together like that. So this is going to be my first angle, and this will be my second angle. Just like here we have a first angle minus a second angle. So if I then copy this, they tell us that it becomes cos of your first angle, which is 90 plus b, times by cos of your second angle, which for us is a, then plus sin of your first angle times sin of your second angle, which is a. Okay, now I know from cofunctions that cos 90 plus actually becomes a negative sin. Sin 90 plus just stays positive cos. Okay, and then I'm just going to switch the order around, so it's going to be cos, or we could write it as, we could switch these two around, so sin a cos b minus, and then I'm switching these around as well, cos a sin b. And so there we've proved it. This one, hence, or otherwise, determine the general solution of this equation. Okay, so this over here is a compound angle formula, which, you know the compound formulas, we've even got it right over here. We've got sin, cos, minus, cos, sin. Sin, cos, minus, cos, sin. So we're going to rewrite this expression back into that. So it becomes the sin of 48 minus x. Okay, now don't think about double angles over here. That's going to make your life more complicated. This actually drops back to a grade 11 kind of question where you've got, we're not going to use tan because these angles are different, but this is the one where you can change this one using cofunctions. Remember that from last year? 2x. And now, you see we have sin on both sides. And so you say 48 minus x equals to 90 minus 2x. But then stop there. A lot of learners, they try solve. So this becomes your angle. And this becomes your reference angle. So now we're going to work in the quadrants where sin is positive, because you see they didn't have any negatives in the front, so it's where sin is positive, which is quadrant 1 and quadrant 2. So for quadrant 1, you just literally take your angle, and then you don't say 180 minus, 180 plus, 360, none of that. Not for quadrant 1, KEZ. Now we're just going to solve. I'm going to bring this 2x over to become like that. I'm going to bring the 48, and so we end up with x equals 42 plus k360, k element z. Now for quadrant 2, you just start with your angle, 48 minus x. Now for quadrant 2, we always say 180 minus your reference angle, so that's going to go in brackets because it's more than one term. Okay, now we're just going to say 48 minus x equals to 180 minus 90 plus 2x plus k360. Okay, so we're going to take the 2x over to the other side, so we end up with negative 3x. And then 180 minus 90 is 90. Take away 48. Okay, and so we end up with negative 3x equals to 42. And then we divide everything by negative 3. So, sorry, it's a bit messy here. And so we're going to end up with, what's 42 divided by 3? 16. 14, Kev. Come on, brother. Minus 14, take away k times 120. Some teachers will leave this as a negative, as a positive. It's absolutely fine. It's weird, but it is okay. Now, what's crazy about general solution, and the reason I don't like general solution, is that if you decided not to change this one, but you decided to change this one into cos, then your answer will look different to, what did we get? We got this one and this one. Your answers will actually look different. Not the best, because learners often think that they're then wrong. But if you look on the memo to this paper, November 2023 final exam paper, you'll see that they show the two different techniques. Simplify sin 3x plus sin x over cos 2x plus 1. So we're definitely going to use our double angle formulas, because whenever I see a 3, I know that it's better to change that to 2x plus 1x. Okay, so here are all the formulas. So as I said, the first thing I would do is change that sin 3x to sin of 2x plus 1x. Don't change the cos 2x right now. Let's first just check and see what happens to the top. So I'm going to use this over here. And so that ends up becoming sin 2x cos x plus cos 2x sin x plus sin x. At the bottom, just leave it for now. So what I think we could maybe do at the bottom is try to get rid of this 1. So we're looking for a minus 1, so I would use that one over there. Because then you end up with, and then this sin 2x, we normally always change sin 2x using this one over here. So that's going to become 2 sin x cos x, and then we still have this cos x. Don't change that one right now because you would just be guessing which one to use. Okay, and then we're going to change this to 2 cos squared x minus 1 plus 1. You see how these now cancel? And so that's where we're at. And so if we simplify a little bit now, we end up with 2 sin x cos squared x, and then cos 2x sin x plus sin x, and then at the bottom 2 cos squared x. Now at the top, I see we can take out a sin because there's a sin in every term. So we're going to take out a sin, and then you're left with 2 cos squared x plus cos 2x plus 1 over 2 cos squared x. Now, I would change this cos 2x to try get rid of this plus 1. So we need a minus 1. So I would use this one again. And so 2 cos squared x plus. Now we're going to change it to 2 cos squared x minus 1. And then there's a plus 1 over here. Okay, so these cancel. And so what we now have is sin x Now 2 cos squared plus another 2 cos squared just gives you 4 cos squared. Now we have only one term at the top and one term at the bottom, so we can cancel, and then 4 divided by 2 is 2, and so we end up with a final answer of 2 sin x. In the diagram, the graphs of 2 sin 2x and g of x are drawn over the interval 0 to 180, and then a is that. Alright, mate. So that's f, and then this is that one, and then here we've got this, and then that. First question, write down the period of f. Now, period of a, for any kind of graph, is equal to the original period of that graph. I'll explain that now, divided by k. So, or let's call this the new period. So we know that a normal sin graph normally repeats every 360. That is called its period. So I'm going to put that as the original. That is for a standard sin graph. Now your k value is the one in front of x, which is a 2. And so that's going to be 180. What that means is that this graph repeats in 180. You could have actually seen it over here. See how it completes one cycle? Only 180 degrees. So the period is 180. Determine the range of g, which is the green one, over the following interval. Okay, so the range of g. Okay, that's quite interesting. You can see it starts here and it ends, or its highest value is here. Okay, so that would be equal to a 1, but it's a bit difficult to know what its lowest value is. But I'll show you what to do. But the highest value is 1. I think so. Let's just double check. Come on. Yeah. And if I look at this, that graph has just moved 45 degrees left. Okay, so the highest value is going to be at a 1, but the lowest value we don't know. So what you can do is, we know that the lowest value is here, and you know the x value here is 0. So you can plug 0 into that equation, and then if you had to go work all of that out, or just plug it on your calculator, you're going to get negative square root 2 over 2. And so that is the lowest value, and then the highest value is 1. So you could say that y is an element going from the lowest value to the highest value, like that. If you prefer interval notation, then you would say that to, oh, what are you doing, Kev? That was embarrassing. Up to there. This question here says, determine the values of x where this happens. Now, if you've watched my videos on these type of questions, they're pretty straightforward. You're just going to use a table. So remember, you put f of x and then g of x, and then what happens if you multiply them? So if f of x is positive, g of x is positive, then two positives multiplied make a positive. If f of x is positive and g of x is negative, then when you multiply them, you get a negative. If f of x is negative, g of x is positive. Are we just going through all combinations at this point? Okay, so they want to know, when you multiply them, it must be a bigger than 0 answer. So it means it must be positive. So we don't want this category, and we don't want this category. We only want the categories where we end up as a positive after you multiply them. So what I then do is I think of, this is situation 1 and this is situation 2, and I go look at situation 1 first. So where is f of x positive? So where is f of x above the x-axis? Well, that would be here. Now, inside that interval, from there to there, is there a place where g is also positive? Well, yes, that would be there. So then the answer goes from 45 up to 90. So that's our first answer. We could say x is an element going from 45 up to 90. If you prefer set builder, you could say that. Then we're going to say or, and now we're going to go look at our second scenario, which is this one. So now we're looking for places where f of x is negative. So that would be here. Now inside that interval, from here to here, is g of x negative? Well, no, because we can see g of x is positive. It's above the x-axis. So this one gave us no solution, and so this is the answer. Either interval or set build or whatever you prefer. Okay, now this one says this ugly expression. Now all you do with that is you actually just go do this. You get the graph by itself, so that means the 1 must go over. So what they're actually saying is, where is this yellow graph this one, where is that graph smaller, so that means below, minus 1? Well, here's minus 1. So where is it below that? Well, that would be from here to here. Okay, that's where it's below minus 1. So it's from this x value to this x value, which we don't know what that is. But there's symmetry. So if you have 90 degrees and you have 180, whoopsie, let's go through 180. Now, if you look at this distance, that's from 90 to 105. That is 15 degrees. So that means that this is going to come back 15 degrees. So that's going to be at 165. So it's going to be, and they're saying smaller than or equal to. So we're going to say x is an element from 105 to 165. If you prefer interval, you could, set builder, sorry, you could say, and then we would include. Another graph P is defined as the negative of f of x. Okay? Point D lies on P. Determine the values of k in this interval. Okay, so the graph of P is the negative of f. So if f looks like this, then the graph of P is the complete opposite. So this point will be here, and this point will be here. Okay, like that. And so you're going to have a graph that actually looks something like this. So that is what graph P would look like. Okay, so that's P. Now they're telling us that there is a point K and negative 1. So negative 1 is here. So on that blue graph that we've just drawn, it would be there and there. So that would be K and negative 1, but it can also be this point here, K negative 1. And our goal is to find the value of K. So can you see that this point, well, how could we do this? Okay, yeah, we could go that the graph of P is the negative of f of x. So the graph of P is negative 2 sin of 2x. Okay? Now, we want to know where is that graph equal to minus 1. So we make the y value minus 1, and we divide both sides by minus 2, and so you end up with a half. And we can switch that around if you want, like that. Now it just becomes a general solution kind of question. So we know that you get your reference angle by saying shift sin of a half, and that'll be 30 degrees. Now it says that sin is positive, so that's going to be in quadrant 1 and quadrant 2. So we can say 2x equals to the reference angle plus k 360, k element z. And so x is going to be 15 degrees plus k times 180. So this one's obviously the 15 degrees. Okay, so that's our first k value. Now, if you use quadrant 2, then you say 180 minus the reference angle plus k 360, k element z. And so you end up with 150 plus k 360. Now you divide everything by 2, you would end up with x equals to 75 plus k 180, k element z. So this would be 75. So k would be 15, or k would be 75 degrees. This question says graph H is obtained when G is translated 45 degrees left. Determine the equation. Write your answer in simplest form. Okay, so graph G is currently this. Now they said that H is that graph moved 45 degrees left. How do you show that a graph is moved 45 degrees left? Well, you say plus 45 degrees. Remember, plus means left, minus means right. And so you end up with x plus 90, which is the same as 90 plus x, because when you plus, order doesn't matter. Now you need to know or identify that this is a cofunction, and that cofunction becomes negative sin x, but we already have a negative there. So we're going to get h of x is equal to negative sin x, and so it actually just becomes positive sin x. In the diagram, S, T, and K lie in the same horizontal plane. RS is a vertical tower. The angle of depression, okay, everything they've said is on the diagram, and the area of STK is Q. Okay, we must remember that. TS is P. Okay, so the area of STK, where are you? STK, oh, there. Okay, so this triangle on the floor, its area is Q. Okay, so the first question for 2 marks. Determine the length of SK in terms of PQ and theta. SK. Okay, well, we know that this is not a 90-degree triangle necessarily. So we know that to find the area of a triangle that is not 90 degrees, we usually use half A, B, sin C. But now we know that the way that that formula works is you need an angle, and then you need the 2 sides next to that angle. So we know the area is Q. I could use this angle. So, and then if I use this angle, then I have to use this side and this side. So that's going to be ST, and then SK, and then sin of that angle, which is alpha. I keep calling it theta. And so Q is equal to a half times P times SK times sin of alpha. Now, we need to get this by itself. So I'm going to multiply this 2 up to the top, so we end up with 2Q. Okay, now to get this alone, you're going to say 2Q over P sin alpha. 2Q over P sin alpha. This question says, show that RS is that. Okay, well, we know from alternating angles that this angle here is going to be beta. Okay, so we could say that angle SKR is going to be beta. Okay, now if that's beta, okay, now we have this side, and they want us to find this side. Now it is a 90-degree triangle, so we're just going to use grade 10 SOHCAHTOA. A lot of grade 11s and 12s forget about grade 10 trigonometry. They just want to use the grade 11 formulas. It's not wrong, but it's making it a bit more challenging for yourself. So we've got the angle beta. We're looking for the opposite, and we have the adjacent, which is this one. So that's tan. So we could say that the tan of beta is the opposite over the adjacent, which is SK. Now I know that SK is this, but I don't want to write that the whole time, so I leave it for as long as I can. So I'm going to get RS by itself by multiplying SK up to the other side. Now I will substitute SK in place, which is then 2Q over P sin alpha times by the tan of beta. And that's exactly what they have here. Okay, so we have RS now as 2Q tan beta over P sin alpha. Alright, so now this one says calculate the size of alpha if alpha is less than 90, RS is 70. Okay, so we have RS, we have P, and we have Q, the area of Q. Okay, so I think what we can do, it's not a difficult one, that it's just a bunch of substituting, is I think let's just go back to that area of STK again. We said it was a half times ST times SK times the sin of alpha. Now we know the area is Q, but they've told us that that's 2,500. ST is P, but they've told us that that's 80. Okay, and then SK is all of this, so that's going to be 2 times Q, which is 2,500, over P, which is 80, times the sin of we don't know. Okay, and then multiplied by the sin of alpha. Now this formula doesn't work because look, those cancel, and so you're probably going to end up with 2,500 equals to 2,500. Oh well, we tried. So that's not the way to do this question. Okay, then let's try this one. RS equals to 2Q tan beta over P sin of alpha. So RS, where are you? RS? Oh, here. RS is 70. This will work. Now Q is 2,500 times by the tan of beta, which they said is 42 degrees, Yeah, this will work. P is 80, and then sin alpha. Okay, so just multiply the sin alpha up to the other side. Then the rest just stays as it is. We can divide by 70, so that'll end up going to the bottom here. There we go. You can go type all of this on the calculator, or you can actually just go shift sin of all of that. So shift sin of 2 times 2,500 times tan 42 over 80 times 70. And that'll give us 53.51. You don't need to worry about ambiguous case or anything like that because they said that alpha is less than 90. In the diagram, O is the center. Use the diagram to prove the theorem which states that the angle subtended by the chord... Okay, so it's pretty much they want us to prove the center chord theorem where... Not center chord theorem, but the angle at center, where this one should be double this one. So there's multiple ways to prove this one, but one of the ways... I show different ways, but one of them is to first do a construction line from K... Go through like that. So you must just say here, construct... KO and then produced. It just means that we let that line go on a little bit. So now we have a O1 and a O2. Okay, now look at this carefully. If you look at this triangle here, we know that this angle is the exterior angle. And we know that the exterior angle of a triangle is equal to the sum of the two opposite angles. Okay? We can call this K1 and K2 now. So we can say that angle O1 is equal to K1 plus angle T. And that's because of exterior angle triangle. We also know that this and this are the same because they are the radii. That means that these two angles are the same. So we could say that angle T is equal to angle K1 because they are the angles opposite equal sides. So then what I could say is that angle O1 is then equal to K1 plus K1, and so angle O1 is equal to 2K1. I'm now going to repeat that exactly on this side. It really can't get easier. So we'll say that angle O2 is equal to angle K2 plus angle P because of exterior angle triangle. But we also know that this and this are the same because of the same reason as earlier. So we could say P is equal to K2 because of angles opposite equal sides. And so we could say therefore O2 is equal to K2 plus K2. And so O2 is 2 times K2. So now we can look at what this whole angle is. So what is this entire angle going to be? Well, that's going to be O1. Whoops, why am I doing that? What is O1 plus O2? Well, O1 plus O2 is going to be this plus that. Now take out a 2 as a common factor, and there we have it. So what we are now saying is that angle O1 plus O2, which is angle TOP, is double K1 plus K2. But K1 plus K2 is just this entire angle, which they called TKP. So we can say TOP is then going to be 2 times angle TKP. In the diagram, O is the center of the circle, and ABCD is a cyclic quad. Duh! Touches all 4 sides of a circle, so it has to be a cyclic quad. OB and OD are drawn. If O1 is equal to 4x plus 100, and angle C is x plus 34, calculate, giving reasons, the size of x. Right, when they give you a question like this, I've seen this many times, it's going to have like a diamondy kind of shape, and they typically going to give you something in the center. All you must remember is that this angle will always be double this angle, okay? And this angle will always be double this one. So it's opposite. So this one goes with that, and this one goes with that. So this one is going to be double that, and this angle on the outside here, this one, angle O2, that'll be double that one. Okay? So, for example, what we could say is that this one is going to be double angle A. So angle O1 is going to be 2 times angle A. And that is just because of angle at center equals 2 times angle at circumference. So that means that this one is going to be half of 4x plus 100. So it'll be 2x plus 50. So angle A is going to be 2x plus 50. Now, we know that this is a cyclic quad. What do we know about the opposite angles of a cyclic quad? They add up to 180. They're supplementary. Angle A plus angle C must be 180. Op angles cyclic quad. Just go sub in the values now. So A is 2x plus 50. C is x plus 34. It's actually a very easy question. So that's 3x plus 50 plus 34 is 84. Take the 84 to the other side. You end up with 96. Divide both sides by 3. You get 32 degrees. In the diagram, O is the center of the larger circle. OB is the diameter of the smaller circle. Okay, we must remember that. That's the diameter of the smaller circle. Put a little dot there to remind us. And chord AB, blah, 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 blah. Okay, write down the size of angle OMB. OMB. Okay, it's going to be 90 degrees. Why? Because in the small circle, we've got a diameter. And a diameter always makes 90-degree angles. That's angles in a semicircle. So we could say 90 degrees angle in semicircle. Okay. Now, if AB is square root of 300, so that's square root of 300, and OM is 5, calculate the length of OB. Okay, very easy question, because one of our first theorems we learned in grade 11 is that if you have a circle and you have a center and you have a chord and there's a line from the chord at 90 degrees, then it automatically divides these two into 2 equal halves. That means that for us here that AM is going to be the same as MB, right? AM and MB. And that is because we had a line from center which was perpendicular to chord. Don't say to the midpoint of the chord. Your reason must always be what was your reason. So the reason was that that's 90. From that, we can say that these are midpoints. Okay? And so that means that the length of MB is going to be half of the root of 300, which would be 5 square root 3. Okay. So now we have a triangle that looks like this. MB with 5 root 3, 5, and they just want us to calculate OB, Pythagoras. And so we can just say that OB is going to be, or OB squared is going to be OM squared plus MB squared. And so OB squared is going to be OM squared plus MB, which is 5 root 3 squared. And so OB squared is going to be 100. Take the square root. OB is 10 units. In the diagram, ABCD is a parallelogram where the length of AB is 14 and AD is produced. Okay, so AD to DE. AD to DE, so that's 4 to 3. So you say 4x and 3x. EB intersects DC and F, and then EB is 21. EB is 21. Okay, so this length here is 21. All right. So, first question, calculate the length of FB. Okay, so that's pretty straightforward. If you just look at this triangle here, then we've got 2 parallel lines because that's a parallelogram. So we can use the proportionality theorem, and remember we've got the entire length of EB. So I'm going to start there, EB over, now the thing we're looking for is FB, okay, so FB. Now match that on the other side, so we used the entire length, so that's going to be AE, and then we used FB, which is going to be DA. Now you could say prop theorem, or the one I've been using more recently is line parallel side of triangle. Now we're just going to go full in, so EB EB is 21. FB is what we're looking for. AE is going to be 7x because it's these two together. and then dA is 4x. So the x's cancel. Cross multiply now, so the 4 goes there, the FB goes there. So you end up with 21 times 4 equals to 7 multiplied by FB. That's going to give us 84 equals to 7 FB. Divide both sides by 7 and you get 12. So that's 12 units. Okay, so if FB is 12 for this part, then this part would have to be 9, because together they must make 21. Prove with reasons that this triangle is similar to this triangle. So EDF similar to EAB. So the first thing you would realize is that these angles are common. So you could say that angle E is equal to angle E, and that's because of common. The next one is easy. These two lines are parallel, so we could actually just use corresponding angles there. So angle D, or let's call it EDF, is going to be the same as angle A, and that's because of corresponding angles, because the line DF is parallel to AB. Now with similarity, the third angle is automatically going to be the same. You could use corresponding again if you want to, it doesn't really matter. I won't lie, this is a really easy question. So we would say EFD is equal to angle B, and you could say sum of angles in a triangle again, or you could say corresponding, but I'm going to go sum angles in triangle. And so therefore these two triangles are similar. EDF is similar to EAB. Okay, done. Calculate with reasons the length of FC. Well, you see, we know that this entire length here is 14, because it's the same as this one, because it's a parallelogram. So if we could calculate this, then to get FC you would just subtract 14, or from 14. So I think what we actually need to do is try to find this length. So take this and make those ratios that we always do. So ED over EA equals DF over AB equals EF over EB. And your reason for that is just similar triangles. Or you could say corresponding sides in proportion. Now you're just going to go full in as much as you can. So 3x, EA is 7x, DF, we don't know, AB is 14. We've got enough information. EF is 9 and EB is 21. Okay, so we can actually just use these two, for example. The x's would cancel. Yeah, so the x's cancel. Then you can just multiply the 14 up to the top here. You could also multiply the 7 across, but you're going to end up having to divide by that. So you're going to end up with DF as 3 times 14 over 7. And so DF is going to end up being 6. Now, if this is 6 and that's 14, then FC would just be 14 take away 6, which is 8 units. In the diagram, PQRS is a cyclic quadrilateral. Where are you, PQRS? Yeah, of course it is. Don't know why they say that. If it touches all 4 sides of a circle, they don't need to tell us it's a cyclic quad. We know, bro. Anyways, okay. Such that PQ and PR are the same. That's important. PQ and PR. PQ and PR. Oh, PR is here. Oh, okay. So those two lengths are the same. That's random. PQ and PR. Okay, the tangents to the circle through P and R. Okay, so those are tangents. Meet QS at A. RS is produced to meet blah, 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 blah. PS. Okay. Right, so the first question for 5 marks. Oof, lovely. Prove that S3 is the same as S4. So they want us to prove that this angle and this angle are the same. So the first thing I would look at is, okay, so we've got an isosceles triangle over here, right? So the angles opposite, so this whole angle must be then the same as this whole angle. So we could say that angle R3 must be the same as angle RQP, right? Which is this angle here. And that is just because those are the angles that are opposite equal sides. So, okay, so those are all the same. The next thing is that if you look at the cyclic quad, S3 is the angle on the outside of a cyclic quad. And we know that if you have a cyclic quad, the angle that's on the outside will always be equal to the opposite interior angle. So what is the opposite interior of this one? Well, that would be this angle again. So we could say angle S3 is equal to RQP. And that's just because we have the exterior angle of a cyclic quad. Okay, so we have that now. The next thing is that if you look at this chord, can you see which angles that chord makes? Well, it makes this angle, but it also makes that angle, right? So you might just need to take some time and think about that. If you put your finger at P and Q, you'll see that your fingers can come together at S4, but they can also come together at R3. So S4 is the same as R3 because of angles in same segment. So if R3 is the same as RQP and S3 is the same as RQP, then it means that R3 is the same as S3. But if R3 is also the same as S4, then it means we can say that S3 must also be the same as S4. Okay, now prove that SMRC, okay, let's just quickly put down that those two are the same, and that's all the same, and that's all the same. Okay, so SMRC, prove that that is a cyclic quad. How do we prove something's a cyclic quad? Well, 3 methods. Number 1, either you can prove that the opposite angles add up to 180. So that's opposite angles equal 180. Number 2, you could show that the outside angle is equal to the opposite interior angle, so exterior angle. And then the third one is if you have a shape like this, but you've got like a bow tie vibe going inside there, where you could show that these two are the same. This is the angle in same segment. Okay, so check this out. If I look at the cyclic quad, S4 is the exterior angle over there. If you've got something like that and you've got an angle over here, that's S4. That is your exterior angle. So if it's a cyclic quad, that would have to be equal to this. So if we can show that, then it's a cyclic quad. So is S4 equal to CRM, which is this angle? Well, check this out. If you look at this tangent and you look at this chord and apply the tan chord theorem, then that would take this entire angle and it would make this angle over here. So we can say that angle CRM is equal to angle RQP for tan, because of tan chord theorem. But we already showed earlier that RQP was equal to S4. We showed that in the previous question. So therefore, S4 must be the same as CRM, and therefore SMRC must be cyclic because of the converse of exterior angle of a cyclic quad. Okay, so now we know that it is a cyclic quad, so just remember that in case we need that for the next question. So we now know that this angle is the same as that angle. Okay, and then that's about it. So the next question for 6 marks. Prove that RP, where are you? Oh, there you are, is a tangent to the circle that passes through PS and A at P. Okay, so we've got a circle that goes through PS and A. So PS and A. All right. And guys, just a little bit of a tip. Like if you're ever struggling with these questions in the exam, what you could do is actually just write on the paper and just say, I identify as a student who got this question correct. And, you know, technically we're in the 21st century now, so they can't deny you that. If you want to identify as a student that got 100%, well, that is your birthright, and you may do that. And if they don't give you 100%, well, we've got social media now, and you may actually just win this if they decide to take this to court, because you can identify as anything right now. So always keep that in the back of your mind. You guys have the power. So RP is a tangent. So we want to prove that RP is a tangent to the circle at PS and A. So if we draw a circle through PS and A, okay, so let's see how good we can do this. Oh my goodness, Kev, how's that gonna get to a circle, bro? Yo, Kev, oval master. Oh no, man. Oh, you get the idea, okay? So let's just see here. So we want to make RP a tangent. No, let's actually do it a little bit better. So if RP is a tangent, it's always the tan chord theorem. Check here. If RP is a tangent to that circle, then it would mean, now what you go do is you go find a chord. So here's a chord. It would have to mean that there's your chord. Now if you had to use the tan chord theorem, then you take the angle between that chord and the tangent, which is this one, and it would have, if it is a tangent, it would have to be equal to this angle. So if you can prove that angle P2 is the same as A2, well then it's a tangent. Okay, so I took away all the mess, and what we are trying to prove is that those two angles are the same. That is our goal right now. Okay, so it took me a few minutes to actually look at this one. It's actually weird. It's not a nice question. Pretty much what we can do is, and I don't blame you if you don't like this one. This one wasn't too nice. But if you look at this triangle, I want you to look at S3 and see that as the exterior angle. If it is the exterior angle, then it should be equal to the two opposite interior angles. The sum of those two. So that's P2 plus R2. Okay, and that's just because of exterior angle of a triangle. Right, that's the first thing I want you to see. The next thing is I want you to look at this triangle. I then want you to look at S4 as the exterior angle. And if it is the exterior angle, then it would have to be equal to this one plus this one. Angle A2 plus angle P1. And that's exterior angle of a triangle. So I then want you to look at P1, okay? And the fact that this is a tangent to the original circle. Then take this chord. Then that means angle P1, if we use the tan chord theorem, would be equal to Q2, but more importantly, it would also be equal to R2 from the tan chord theorem. So P1 is equal to angle R2, and that's tan chord theorem. So we can then replace, in this equation here, we can then say that R2 can go over there. So therefore S4 is the same as A2 plus R2. And we also said that S3 was P2 plus R2 from over here. But earlier we showed that S4 and S3 are the same. So if these two expressions are the same, then it means these two must be the same. So if they both have R2, then these two have to be the same. So therefore, or what we can say is S3 is equal to S4. That was proven earlier. So therefore, if these two expressions have to be equal, then if these two are already the same, then these two have to be the same. So therefore, A2 must be the same as P2. And that's what we wanted to show. So because they are equal, it must be a tangent. And that would be converse of the tan chord theorem.